Okay, so Tommy wants to practice vertical circles for a flying show exhibition. What must the minimum radius of the circle be to ensure that his acceleration at the bottom does not exceed 3.0 g and the speed of the plane is 78 meters per second at the bottom of the circle? What is Dave's apparent weight at the bottom of the circular path? Express your answer in terms of his true weight, and that's for B. So, for starters, we need to understand that the minimum radius, we can use the maximal possible radial acceleration, which is a sub r, which is equal to v squared divided by r. And for the maximal radial of the tangential acceleration must be 0. So now the magnitude of the acceleration is a is equal to square root of a sub r square root plus a of t squared. And because of this, the radial acceleration component has a magnitude of 3 at the bottom. So you can see I did a free body diagram, and this is the plane, supposed to be a plane. It doesn't look good, but it's whatever. But it shows the acceleration is going towards the center of the circle, which I drew that a little long actually, but it's supposed to go to the center right here. And so the magnitude of the radial acceleration is a sub r equals v squared divided by r, and that we know that r is equal to v squared divided by a sub r, which is equal to v squared divided by 3.0 g. And I plug in my values for that, and I got that 210 meters. Now, part B, it's what is Dave's apparent weight at the bottom of the circle path. And so we want to find his true weight is what it's asked for. So the apparent weight is the magnitude of the apparent weight of the plane pushing up on him. So I let the y-axis point upward and the gravitational force pointing downward. So we use this formula. Sum of the forces in the y direction is equal to n minus mg, which is equal to mass times acceleration in the mass times acceleration in the y direction. So the acceleration in the y direction is equal to 3.0 g. So that gives us the formula for the parent weight, which is equal to the normal force, which is equal to the m times g plus a times y. Acceleration in the y direction, which is equal to 4 mg.